This is the second half of section 2.2 and just the highlights of finding the areas of normal curves, or underneath normal curves, I should say. And then also talking about how we can figure out if data is actually normally distributed. So if you recall, the empirical rule talks about the fact that the normal distribution has this unique quality of having a certain percentage of values that fall within each one of these 1, 2, or 3 standard deviations, and recognize that this normal distribution right here, where the mean is 0 and the standard deviation is 1 on each side, that this is called the standard normal curve, or the standard normal distribution. And the reason why it's the standard normal is because when we talk about standardizing, we usually refer to how far in terms of standard deviations are we. So one standard deviation is 1 away, and so forth. So that's the idea with that. So what we're going to do is to take a look at how we find the areas when it doesn't fall exactly on the 1, 2, or 3 standard deviations. And so we're going to use our calculator to do that. So if we think about the IQ test that we had before, and we ask the question, what percentile are we at if we get a score of 124? Notice that 124 doesn't fall right on one of the 1, 2, or 3 standard deviations. It's actually between 1 and 2. And so in order to do that, we're going to use a calculator function that you can either use on the embedded one on your Chromebook or a handheld one. And that's underneath the distribution menu, which is second vars, and then normal CDF. So when you do that, it's going to ask you for some characteristics, and you're going to think of what's the lower bound, the upper bound, the mean, and the standard deviation. In this case, the lower bound is going to be really negative infinity. Even though you can't have an IQ score lower than 0, the mathematical function continues on. So we're going to use that as our lower or upper bound. We're going to continue all the way. So you could type in on your calculator. Sometimes it will use 1 and then e to the 99th power. The e key is in second comma, but you can also use that. And so the key idea is when we do a normal CDF like this and we find the area, in this case 0.945 or 94.5%, we do want to include these texts when we're showing our work, so that each one of those values has a connection to a piece of the curve. So then, of course, the step 3 is always to give the answer with context, and in this case, a person who has a score of 124 is going to be at the 94.5th percentile. So now I want to switch to the study guide, and I want to talk a little bit about some of the problems in the study guide. So in your study guide, there's a few problems that deal with finding the area of the normal curve, and it's around the CDC's data on 12-year-old boy male heights, and we were told that they're normally distributed with a mean of 149 and a standard deviation of 9 centimeters. So in order to look at some of these problems, it might be a good idea to actually draw the normal distribution of heights and label each of the 1, 2, and 3 standard deviations, both above the mean and below the mean. Now the question in letter A is what percent of the 12-year-old males are less than 160? So let's start off by drawing our normal curve and then just labeling the values of 1, 2, and 3 standard deviations from that. And you can see that if we do that, 160 is actually going to land right here, and then we want the area less than that. So that means that we're going to shade to the left, and we want all the area lower than that. So this is also a measurement of percentile. So when we calculate this, we're going to use our normal CDF function on the calculator, and again I'm using the -1e to the 99 power, and then we'll go ahead and calculate this, and it turns out that it's 0.889, and you can check on your calculator to make sure that that's actually what you get. But then that gives us the fact that 88.9% of the 12-year-olds are less than 160 centimeters tall. So that's a good example of the types of problems that we'll see, obviously, when we talk about the normal distribution. Now, in question letter B, it says, what is the standard normal distribution? And again, I want you to recall that when we standardize a value, we use what we call a z-score, and this gives us how far the values are away from the mean. So we take the value minus the mean, divide it by the standard deviation, and that would give us a z-score. So anytime that you see a problem referring to a z-score, they are pointing you to this normal curve where the mean is 0 and the standard deviation is 1. You can certainly find the areas of standard normal curves on your calculator as well, because again, you know the mean and the standard deviation. So that is a good clue for that. Okay, when we want to, I want to take a look at if we wanted to look at the percent of 12-year-old males' heights that are greater than 145 centimeters tall, again, I would encourage you every time you see a problem like that is to draw a picture of the normal distribution of heights and give 1, 2, and 3 standard deviations away from the mean. Okay, so that way you always have a good picture of what you're looking at. In this case, we're looking at 145. 145 is going to look probably right about there. And then we want all of the heights that are greater than 145. And so if we look at greater than, then we're going to be able to, again, calculate everything to the right. So in this case, the lower bound is 145 centimeters, and the upper bound is positive infinity. If you wanted to type in 1,000,000, you certainly could do that as well, or something like that, and that would give us a value for each of those. And so we'd find out that 67.2% of the males have heights that are greater than 145 centimeters. Okay, so if we take a look at the next one, now this is going to be one of those where it's in between. So we want to come up with a value where it's 140 to 160. So 140 to 160 is the value or the area in between those 2 points. And so again, our lower and upper bound are going to be those boundaries, 140 and 160. The mean is 149, the standard deviation is 9, so we can see that the values of those would give us an area of 0.731, or 73.1% of 12-year-olds are going to be between 140 and 160. So the other main idea is if we find areas from the normal distribution, we can find locations if we're given a certain percentage of that. So remember our empirical rule example where we wanted the 84th percentile, and it happens to be using the empirical rule that we can get 84% just by looking at one standard deviation above, and then the rest of the half below will give us 84%. But what happens if we wanted if we wanted an IQ test that was below 88%? Now that's not percentile because percentile is below, but if you think about the percentile, that would give you 0.2. 0.12 or the 12th percentile. So there you can find, actually, we want to know where this location is. Well, it's an IQ score of somewhere between 70 and 85, probably closer to 85. But what we want to do here is we can use inverse normal on our calculator, which is another command in the distribution menu. And if you use inverse normal, you want to use the area of the area to the left. Now, some calculators allow you to use the area to the right as well, and you'll see that in some of yours. But in general, you concentrate on using the area to the left or the percentile. So if we want 88%, we actually want the 12th percentile. So again, if you're writing this down either on a free response question or just showing your work, you always want to include what those numbers mean. So area, mean, standard deviation, and then this gives us the value 82. A score, so a IQ score of 82 is going to be below 88% of the test takers with that. So these are some key points to remember, and again, these are on the slides in your folder, so you can use those as well, but just keep that in mind when you are using the calculator to find areas. So another good thing for us to recognize is that not all data is normally distributed, and all of these normal calculations only work if the data follows a normal distribution. So there's sometimes when we're given data, we don't know if it follows a normal distribution, so we should assess why that is. And there's a few ways we can do that. We can actually look at graphic summaries like a histogram and a box plot, which might give us an idea of symmetry. We might use numerical summaries where we want to look and see, are the mean and the median about the same, because that would tell symmetry. Also, do the min and the max sort of fall in with where the empirical rule is? So does it follow the empirical rule, which means, you know, do 68% of the data points fall within one standard deviation? Do 95% of the data fall within two? But with summaries, sometimes we don't have the data, and what you could do is just check the min and the max, and to see, does the minimum and the maximum fall within about 2 or 3 standard deviations. If it falls within about 2 or 3 and there is symmetry, that's pretty good indication that it's probably normally distributed. Now, another way that you could look at this is with a plot, and a very common plot we use is called a normal probability plot. And these are, for the most part, you can create them on your calculator, but for the most part, good, you know, a computer output will give us that. And what we're looking for is that it actually compares the data to the standard normal curve, and to see how well does it match up. And what we're looking for with this is we're looking for a straight line. So on the left here, or on the right here, sorry, is a normal probability plot of this data. And notice that there is a little bit of fluctuation, but in general, this is a straight line. And if we say it's roughly normal, the normal probability plot, then we would say that it's roughly, if it's roughly linear, if it's roughly linear, then it's roughly normal. And this is a pretty good way, because, you know, this histogram might not look approximately normal, but we can see that it does follow a pretty straight line, which does mean that we can approximate. And that's why we usually use the phrase approximately normal or roughly normal. Here's a skewed right distribution that is clearly not going to follow a normal distribution. And here's the normal probability plot that goes with that. So you can see that this is clearly not a linear plot, and that would give you good indication that it is not a roughly normal distribution. So if you were only given this plot, the indication would be that it's not normal. Here is a symmetric mound-shaped distribution, and notice that this one does give us a roughly linear pattern in the normal probability plot. So we would say that this data is roughly normal. And so then if you did use a normal distribution with the mean and standard deviation from this data, you could use the normal curve to estimate different areas or different unemployment rates and the frequency there. And so that's kind of the goal with all of those. So this is the end of section 2.2. Make sure to look at the book and to recap some of those main ideas that we had from the learning targets in all of section 2.2.